All right, let's take a look at another even-odd example. Suppose n is an integer. We're supposed to show that if 3n plus 5 is even, then n is odd. Let's take a look at the proof outline. First of all, let's record the statement that we're trying to prove. We have 3n plus 5 is even, implies that n is odd. Now, we know how to do proofs like this directly. If this, whatever it is even, we assume that it has the form twice an integer, and then we try to demonstrate that this would have a form twice an integer plus 1. What we're used to doing is going from a simple expression like n to a more complex expression like 3n plus 5. Now we are asked to do it the other way. We're going from a more complex expression to a simpler expression. And remember, we did a problem a little bit ago when we were supposed to show that if n squared is even, then n is even. And again, we had to go from a more complicated expression to an easier one, and that did not work out very well directly. So what we're going to do is we'll have to get this up front somehow so that we get to work with n to begin with and not with this. Remember that proving a contrapositive of a statement is equivalent to proving the statement itself. So why don't we write the contrapositive of this? So here's the contrapositive. What you do is you switch them around, but as you switch them, you have to negate each one. So I'm going to say not n is odd implies not 3n plus 5 is even. And of course, it's a lot easier to think about it as n is even implies that 3n plus 5 is odd. N is even implies that 3n plus 5 is odd. And now we have a much simpler problem to work with. So here's the proof really quickly. Suppose n is even. Then n is equal to 2k for some integer k. Well, now that we know what n is, let's go ahead and look at 3n plus 5. 3n plus 5 is equal to 3 times 2k plus 5, which gives us 6k plus 4 plus 1. And now we'll take these two and factor 2 out. And this gives us 2 times 3k plus 2 plus 1. So now we have written this integer in the form twice an integer plus 1, which implies that this is odd. This is an integer. So 3n plus 5 is odd. And since we have just proved the contrapositive, we know that the original statement is true, and we are done.